Good day all, and welcome once again to my YouTube channel. So today we are going to be looking at chemistry, and the topic that we are looking at today will be on water. And water, we are going to be looking at it under three headings. We have the composition of water, treatment of water, and hardness of water. Now we'll start by looking at the composition of water. Water shouldn't be new to any chemistry student. Of course, even from our lessons of initials of chemistry, we have water to be a chemical compound that is made up of hydrogen and oxygen in the ratio 2 to 1 respectively. So the formula of water is given to be H2O, meaning the ratio of hydrogen is 2 and the ratio of oxygen is 1. All right. So then we can say that the chemical composition combination of hydrogen and oxygen can form water. Or you could also go by saying when hydrogen is burnt in air, of course, you know that the component or constituent of air that supports burning is oxygen. So when it is burnt in air, it produces steam. But that reaction needs to be carefully carried out. Why? Because when hydrogen burns in air, it gives a violent or explosive reaction. So you can actually back that reaction up with this equation H2 plus O2. Both are gases, and that ends up giving you H2O gas, being what? The steam. By balancing, you have this reaction. So the reaction that results in the formation of water can be represented in this simple way. All right. Now we have some unique features of water, and two of the amazing properties of water I'll be mentioning includes one. Water is characterized by a high boiling point. Of course, the boiling point of water is 100 degrees Celsius. Then there is still another compound that contains hydrogen, and that compound is hydrogen sulfide, H2S. Hydrogen sulfide is characterized by a very low boiling point of about minus 62 degrees Celsius. So why is it that water is characterized by a high boiling point? Of course, you know, this H2S has a higher molecular weight than H2O, water, because water is 18, while this one is more. So what is expected is that this one is supposed to be having a higher boiling point, but no. Water having a lower molecular weight is now having a higher boiling point. And why is that? It's because there is hydrogen bond between two molecules of water, meaning if you have H and O and H, and then you have another H and O and H. Between these two molecules of water, you are having the formation of hydrogen bond. And it takes a very high application of heat energy to cause the breakage of the hydrogen bond in order for water to boil. That's the reason why the boiling point of water is characterized by a very high value, being 100 degrees Celsius. Another very amazing feature of water is that ice that is supposed to sink in water does not. And why is that? It is because ice has a lower density than the liquid form of water. Meaning all those cold regions of the world, those cold countries of the world, they usually experience formation of ice in their sea. But then again, these ice do not sink, they only float. And what is responsible for the floating action of those ice is due to what? A low density of such ice. So you see the amazing features of water. Now let's continue. We said the formula of water is H2O. Can we also say that water is actually an oxide of hydrogen? Of course, yes. Water is simply an oxide of hydrogen because the constituent of water remains H2O. It is a chemical compound and not a mixture. It is only when you add other substituents to water and then there is the establishment of physical combination that you can say that it is a mixture. But when it exists on its own, it remains a chemical compound. Let's continue. Looking at the next, being the treatment of water. Now, water needs to be treated before it is being supplied to various homes for domestic usage as well as industrial usage as well. Of course, you know that before water is being transported for township usage or municipal usage, it has to be treated properly. And we have diverse treatment processes for water. I'm going to be listing some of them on the board. So the treatment processes of water includes, we have the first being coagulation, then we have the second being sedimentation, then we have the third being filtration, then we have the fourth being chlorination, then the fifth being addition of other supplements, which includes fluorination. Then we have iodination, and lastly we have liming. So these are important processes that are involved in the treatment of water. I will just take them one after the other, so pay attention. Coagulation is also called flocculation. That's another name for it, flocculation. And it's simply a process that involves the addition of alum to water in order to coagulate the fine debris or debts in water into a big flock. All right. Now, listen attentively. The alum being added to water, most times the one that is commonly used is potash alum. You can still remember one of my lessons on salt, I explained about double salt, telling you that potash alum is an example of double salt, right? So hence, you can see the application of potash alum here, that it can function as a coagulant or a flocculant that tends to bring together fine debris into a big flock. The next process is sedimentation. After you have already added alum to make the fine debris settle and to form a big flock, then placing it in a settling tank, that's sedimentation, is to allow all the big flocks to settle at the bottom of the tank so that you can carefully filter. That leads us to the next process, filtration. Now, it involves the passage of the water through a filter bed, and filter beds can usually come in the form of gravels, sands, or even stones that tend to trap these fine debris or big flock, so as for them to prevent their entry into another container. Then you have your clear water. Can we see that these processes, coagulation, sedimentation, filtration, they are to make the water clear but not clean. All right? So the cleaning action to make the water to be potable, meaning the one spelled P-O-T-A-B-L-E, meaning something that is fit for consumption. So to make the water potable, you have to start with the chlorination process. And what is chlorination? Now, chlorination simply is the addition of a calculated amount of chlorine in order to kill germs. Now, the chlorine needs to be calculated because if it is not in that appropriate amount, it can be harmful when consumed. Again, addition of chlorine does not only kill germs, it also functions as a good oxidant that helps in the removal of odors in the water. That's an interesting fact. So take cognizance of that. The next is fluorination. So fluorination is simply the addition of fluorine in order to prevent tooth decay. Okay? Then while this one is the addition of iodine in order to prevent goiter. Alright? So iodine is being added to water to prevent goiter, while fluorine is being added to prevent tooth decay. Then liming is the addition of calcium hydroxide, which is also called slaked lime, in order to regulate the pH of water as well as to improving the taste of water. Alright? So that's all about water purification or treatment process for municipal usage or township usage. All right. So the next on the list is hardness of water. Let's get right to that. Hardness of water. Hardness of water. Water is said to be hard when it does not easily lather or foam with soap. I go over that again. Water is said to be hard when it does not easily lather or foam with soap. So it means that it tends to waste your soap. You'll be washing with hard water and then you're using soap, and then all of a sudden you don't find your foam coming out. It tends to waste and is a stressful process. All right. So it means just like I just said something about hard water. Is there the existence of soft water? Of course, yes. A water that is not hard is said to be soft. All right. So then, let's see the different types of hardness of water. The types of hardness of water. There are two types of hardness of water. The first is the temporary hardness of water, and we have the permanent hardness of water. So there are two types of hardness, don't forget, the temporary and the permanent hardness of water. So we are going to start by looking at the temporary hardness. But before I start, I'll just give you a main difference between temporary and permanent. Now, the reason why this one is called temporary hardness of water is because it can easily be removed by boiling. Listen, the reason why it's called temporary is because it can easily be removed by boiling, while this one cannot be removed or easily removed by boiling. All right, because the compounds that result in formation of permanent hardness of water, they are heat stable compounds. Don't worry, I'm going to explain all that. Let's start by looking at temporary. Now, for the temporary hardness of water, the temporary hardness of water. Water is said to be temporarily hard when there is the presence of dissolved calcium or magnesium hydrogen carbonates in water. Of course, it could be either the calcium hydrogen carbonate or the magnesium hydrogen carbonate. When dissolved in water, because they are soluble salt compounds, they have the tendency to form temporary hardness of water. So it means the presence of either this calcium hydrogen carbonate dissolved in water or magnesium hydrogen carbonate dissolved in water can form temporary hardness of water. But mind you, what are the ions that are responsible, the metallic ions that are responsible for that temporary hardness? They are calcium ion or magnesium ion. So don't forget that, all right? And these two, they dissolve, they are soluble. So now, we have seen how the temporary hardness of water are formed. Then now, let's see how we can possibly remove this temporary hardness of water. Remember, when I even gave definition, I said temporary hardness of water is simply hardness that can easily be removed by boiling. So what does that mean? It means these two compounds that are responsible for causing temporary hardness are unstable to heat. And remember that it is the ions we are interested in removing. So if you boil a water that contains this, a dissolved form of this one, when you boil it, this is what happens. Remember that the application of heat on this causes the decomposition of the substance. And when it decomposes, our main focus of removing the temporary is removing this ion. So by the application of heat coming from boiling, it tends to split this, releasing CaCO3 plus H2O plus CO2. Now, looking at this thoroughly, you get to know that our main interest is to removing this calcium ion. So we must have a precipitated form, an insoluble form of this calcium ion in the product, and of which is present there. Now, this compound is considered to be an insoluble compound. You can refer back to our insoluble salts. So we can easily filter off, because of course we have a gaseous product being this one. This is a gaseous product, this is liquid, and while this one is solid. So what happens is this: you can easily filter this, and then you'll be left with what? Water. Because in that, this one will tend to what? To escape if it's in an open system. All right. So the same thing also applies to this. At the end, when you decompose this one, it gives you magnesium carbonate, water, and CO2, and it ultimately results in the release of that gas. The gas escapes while you filter off the magnesium carbonate. All right. So that's how you can remove temporary hardness. Again, another way that you can remove temporary hardness is by the addition of slaked lime, that is calcium hydroxide. So take for example, if I add calcium hydroxide to water containing this dissolved form of this compound, then it ends up becoming something like this. Let me show you. It becomes something like this: CaHCO3. This is the one that is causing the temporary hardness, and we are adding CaOH2. If I add this to this, it ends up, because I want to precipitate out the calcium that is responsible for it, and then it ends up giving me CaCO3 plus H2O. And of course, when you balance the reaction, you'll be having okay, we have two calcium here, so two calcium here, and then we are having two carbons, and then oxygen is 6 here, and here is 8, and here is 6, here is 8, here should be 2 now because of the oxygen. So hydrogen is 2 here, hydrogen is 2, that's 4, then oxygen is 2, 8, then 8, then calcium is 2, and 2, so everything is balanced. So this is insoluble. Then while this one remains the water, so you can easily filter out, and then you are now left with water. So there are two ways that you can remove temporary hardness. One is by boiling, and two is by the addition of calcium hydroxide, which is also called slaked lime. What are some of the effects of temporary hardness of water? The first effect is that it is responsible for the thawing of kettles and boilers, ring boilers that you use at home. The thawing of kettles and boilers. Of course, when we say thawing, formation of scales on the surface of our kettles as well as our boilers. All right, thus exposing the surface to be easily corroded. That's rusting process. Then the second is the formation of cave pillars. The formation of cave pillars, and cave pillars comes in the form of stalagmites and stalactites. Stalagmites and stalactites. All right. Now these are cave pillars. Stalagmites are simply cave pillars that tend to grow from the ground to the roof. That's for the lagmites. Then while stalactites are cave pillars that grow from the roof to the ground. So it's just like you having something like this. Let's say this one is acting as the roof, and you have cave pillars that are growing from the roof to the ground, and then you have some that are growing from the ground to the roof. So which ones are the ones that are growing from the roof to the ground? They are called the lactites. Then the ones that are growing from the ground to the roof are called the lagmites. And it is due to the presence of what? Temporary hardness of water that can cause that. Then let's progress to looking at the permanent hardness of water. For the permanent hardness of water, when we talk about permanent hardness of water, we are simply referring to a type of hardness in which it is caused by the presence of dissolved salt compounds of calcium ion, magnesium ion, or iron ion. So it means that the three ions that are responsible for causing permanent hardness of water includes calcium ion, magnesium ion, and less commonly known as iron ion. All right. Of course, you know that the ones that are commonly known are calcium ion and magnesium ion, but this one is less commonly known. But though the calcium ion, magnesium ion, and iron ion of tetraoxide 6 salt compounds cause permanent hardness of water. Again, even the chlorides of calcium and magnesium can as well form permanent hardness of water or cause permanent hardness of water. Let me explain. When you have CaSO4 dissolved in water, or NgSO4, or FeSO4, now these three salt compounds can cause permanent hardness of water. can cause permanent hardness of water. Again, even the chlorides of calcium and magnesium. So calcium chloride and magnesium chloride can as well cause permanent hardness of water. So it means that any of these five compounds, when dissolved in water, can cause permanent hardness of water. So don't forget that. Okay? Then, how can permanent hardness of water be removed? Since I made mention of the fact that permanent hardness cannot be removed by boiling, so how can they be removed? Now, you can remove permanent hardness of water by one, the addition of washing soda. Remember that washing soda is Na2CO3.10H2O, that's sodium carbonate decahydrate. Or you can also add caustic soda, addition of sodium hydroxide. You know that sodium hydroxide is also called caustic soda. So you can add caustic soda in the removal of permanent hardness of water. Then there's still another method that is used in commercial purpose, that's on the large scale. They call it the permutate and zeolite method. This one talks about a method involving the exchange of ions, all right? Zeolite method. Okay, so we are going to see how we can use any of these addition. We'll treat on this first two before looking at this one to see how we can use it to removing permanent hardness of water. So let's see that. So we can pick just the calcium sulfate, this CaSO4, as the first substance that is responsible for the permanent hardness, and then we want to add washing soda. We won't use this water crystallization. We'll just use the main substance itself, Na2CO3. By carrying out double decomposition here, it ends up giving you Na2SO4 plus then this one reacting with this to form CaCO3. Remember that what is responsible for the hardness is due to this calcium ion in this substance. Hence, so for we to take up this calcium ion, it means we have to form an insoluble precipitate of a compound that we can easily filter away from the water. And of course, it has been formed here. This is insoluble, very insoluble. So we can easily filter off, and then we are left with this soluble salt compound in water. And of course, by carrying out heating action, since this is stable to heat, then you can obtain the water in a separate form from that compound. All right. Then you can also use magnesium sulfate. If I use magnesium sulfate plus Na2CO3, it's certainly going to give me MgCO3, which is magnesium carbonate, plus Na2SO4. This is also insoluble, so you can easily filter. So that's just the process. All right. Then that's for the addition of washing soda. Then what about the addition of caustic soda, which is sodium hydroxide? Of course, if you try it using this one, it becomes CaSO4 and plus NaOH. So when we carry out the reaction, it's still similar to double decomposition in that this will react with this to form calcium hydroxide. Then you are left with these two, which is Na2SO4. And then balancing the reaction, here is 2 and over there is 2. So everything becomes balanced, all right? So we can easily filter off this one because this is what we are interested in removing, that is responsible for the hardness of water. So when you filter off this one because it's insoluble, then you are left with the other one over there. So that's how you can remove permanent hardness by adding caustic soda. So for the permutate and the zeolite method, this one talks about a method that is usually used on a large scale and is used to removing permanent hardness of water. It involves the use of a substance known as sodium aluminum triiososilicate 4. And of course, that's not really needed for this level at all, but just take cognizance of the fact that it involves the use of that substance, and again, it tends to remove permanent. In summary, all the methods that can be used in the removal of permanent hardness of water can as well be used in the removal of temporary, but the reverse cannot work, in that you can't use the methods for removing temporary to removing permanent, but every method that can be used in the removal of permanent can be used in the removal of temporary. Okay. Then, in summary, the substances that are involved in causing temporary hardness of water could be either this dissolved in water or this dissolved in water. That is calcium hydrogen carbonate or magnesium hydrogen carbonate. These two are responsible for temporary hardness. All right. Then for the permanent hardness, we have CaSO4, we have MgSO4, then we have P or rather FeSO4, then we also have CaCl2 and MgCl2. So all these are substances that can cause permanent hardness of water. All right. So that's that about that. Then, in terms of advantages and disadvantages, of course, permanent hardness or generally hardness at large have advantages as well as disadvantages. So it means when you are making comparison, should be for hard water and soft water. For hard water in terms of its advantages is that one, hard water usually has a better taste than soft water. Of course, soft water is known for its dull taste or insipid taste. All right. And two, hard water is highly nutritious. In fact, I can say that between hard and soft water, the one that is best for consumption remains hard water. Why? Because it contains important chemical elements that helps in the proper functioning of the body's metabolism, as well as even strengthening of the bones and the teeth of animals, and even those organisms that are known to be having shell, and also those that have exoskeleton. It also enhances the strength of their exoskeleton as well as their shells. So you see that's another advantage of hard water. Then again, hard water can be easily transported through lead pipes, meaning it doesn't dissolve in the lead, doesn't dissolve the lead in the pipe. So, but in soft water tends to dissolve lead in pipe, thus causing what is called lead poisoning. All right. And of course, in terms of its disadvantages, you ought to know that hard water tends to waste soap. Yes, it's not really economical. Then secondly, it cannot be used for dyeing of fabrics. Of course, why? Because it can interfere with the dye, thus spoiling the whole reaction. All right. And again, it usually forms scum when soap is used in it, meaning that soap can be used in soft water without giving any issue. But when soap is used in hard water, it tends to form scum. I've seen a question before coming from Jam, and then they were like, the name of the scum that is formed when soap is used in hard water is dash. Now, it's either you call it calcium octadecanoate, is an organic compound, or you call it calcium stearate. Is that you call it calcium octadecanoate or calcium stearate. That is actually the name of the scum that is formed when soap is used in hard water. Again, this calcium can be replaced with magnesium. Don't forget that the two main ions that are responsible for hardness are calcium ion and magnesium ion. So you can replace this as magnesium octadecanoate or magnesium stearate, whichever one. It's very, very correct. All right. So we've been able to understand the nitty-gritty about permanent hardness, temporary hardness, hardness of water in general, and disadvantages and advantages as well. So it's my hope that you've been able to understand everything that we've just gone through about the series of hardness as well as water in general. So please don't forget to subscribe to this channel and share the video, make your friends to be aware of it, and also stay tuned to this channel because more videos will be uploaded very, very soon. I wish you guys all the best. Thanks.